Hi, the following two videos are about celestial coordinate systems. The first video is a compilation of two clips which I got off YouTube, which actually explains the basics of the coordinate system very well. The second video takes the process a little bit further by delving deeper into what the celestial coordinate system looks like and the fact that it actually moves in space as we stand on the Earth. So, the one follows on the other, and there'll be a third one that follows on that to explain celestial time. Okay, so without further ado, let's go.
So this concept of the celestial sphere, which we introduce in chapter 2, this is very important in both this chapter and the upcoming chapter, chapter 3, when we include the moon. And this is not something that's real, but it's a useful tool in astronomy. We are, of course, located here on Earth, so this is where we observe the stars from. And what we do is we imagine that the stars, since they're all at these enormous distances, just in terms of the way that they look from Earth, we can imagine, even though again this is not real, that the stars are all located on this imaginary sphere, and the stars are so far away that their relative pattern next to each other, it basically remains fixed, which is the pattern of the constellations. And then as the Earth rotates at the center, it appears as though these more or less stationary stars, it appears as though they are the things that are orbiting, even though it's really us. We are the ones that are rotating on the Earth due to the Earth's rotation. And so this is what the stars look like throughout the night due to the Earth's rotation. This is something called diurnal motion. So if you were to look in the northern sky, you would actually, and if you were to keep track of the stars throughout the night, you actually see that they trace out these paths. So this is a long exposure photograph right there. All right, let's get to the ecliptic. So here is a cartoon out of our book, and this shows the sun, and it shows the Earth orbiting the sun. And if you imagine that the distant stars are out here, so the celestial sphere is even further out, as we orbit around the sun, different times of the year, the sun, from our vantage point, the sun lines up with different parts of the ecliptic. And as the Earth moves around the sun, as it orbits the sun, the apparent location of the sun as it lines up with the celestial sphere, the sun appears to move around in a circle throughout the year. And that path that the sun takes is called the ecliptic. Here's a nice cartoon out of the book. And this shows the celestial sphere. It shows the path that the sun appears to take over the course of the year, this ecliptic right here. There's another important feature of the celestial sphere, which is the celestial equator, which is just if you take the Earth's equator and you extend it out to the imaginary celestial sphere, you have a path called the celestial equator. And again, the ecliptic is the path that the sun appears to take. Of course, that's due to the Earth's motion around the sun, but to us, if we think of ourselves as stationary, it looks like the sun is orbiting us. There's two locations where the sun crosses the celestial equator, the ecliptic crosses the celestial equator. These are the two equinoxes. This is where the sun is located on the first day of spring and the first day of autumn. And then there's these two other locations where the sun is located on the longest day of the year, the summer solstice, and the shortest day of the year, the winter solstice. So this is a very quick treatment of the ecliptic. It's a very abstract concept. You have to think about it and, try to piece this together. It helps to, just imagine what the sun looks like as the Earth is orbiting around it.
To understand the idea of the celestial sphere, first think of the Earth in space. The stars all around us look as if they could be on the inside of a huge distant sphere. Though the stars are really at different distances, This idea of the celestial sphere is very useful for giving positions in the sky. Now imagine you are close to the North Pole. Here, it is like being on a roundabout because the Earth is spinning on its axis once a day. Every day, each star circles all around you and around the point overhead, which is the celestial North Pole. There is, of course, a celestial South Pole as well, and the celestial equator circles the sky halfway between the poles. Positions on the celestial sphere are specified by two coordinates. Declination, like latitude on Earth, is measured in degrees north or south of the equator. Positive declinations are north, negative declinations south. Right ascension, the equivalent of longitude, is measured in hours from a zero line. An hour is 15 degrees.
Alright, that's it then for celestial coordinate systems, hour angles, right ascensions, declinations, and a little bit about the ecliptic. In the next video we'll talk more about the ecliptic and the first point of Aries and its role in it and how this whole system moves around here. So don't miss it.